So I don't even know if that's accurate anymore. I'm probably closer to the Kittery outlets now at my new house. All right, so Mrs. Crowley takes 18 minutes to drive to the Kittery outlets from her house. So I'm in my car, driving to the outlets. What's the best outlet in the outlets? Where do you guys go shopping?
New Balance.
New Balance?
Oh, yeah.
Ooh, New Balance.
It's also where I work.
Oh.
So,
I'm partial to Adidas, sorry. Though I haven't been to an Adidas outlet in a while. I feel like stuff's just too crazy these days.
Nike.
Alright, so Mrs. Crowley takes 18 minutes to drive to the Kittery outlets from her house. The outlets are 12 miles away from her home. How fast am I going? How do we figure that out? So we wrote a bunch of formulas down yesterday. Which formula do you think we're going to use?
Would it be like 18t times times x equals 12m?
Okay. You're thinking of like an equation. I like where
Oh.
you're going though. You're kind of like on the right track, but if we use which formula, Ethan?
Distance.
Distance
Oh.
formula. What is the distance formula? Which will make it a lot easier. D equals RT. So let's jot that down. Now the only tricky part about this problem is usually when we're talking about speed, what are my units? Miles per hour. Is my time in hours right now? How do I convert 18 minutes to hours? Huh? Not times 60. That would make it much bigger. Divided by 60, right? Because 18 minutes isn't one full hour. It's a fraction of an hour. So if we do 18 divided by 60 to get to my t, what is that? Is that 0.3? Am I making that number up? Is it? So my time is really 0.3 hours to get there. Okay, so that's our t. So I'm going to plug that in place of my t. Which variable are we solving for? R, so that's going to stay in R. And my distance is 12. So what do? Divide by 0.3. So what does that get me? I'll divide by 0.3. It's 40. 40 miles per hour would be my speed. Okay. Am I speeding? I don't know. What road am I driving on? Depends. That's probably an average. I mean, I guess if you're driving on 236, you probably average 40 miles between the up and the downs. It is? There's no 35s? What about an Elliott? Isn't it 35 in Elliott?
Well, yeah, it's 35.
You may drive 40 through
Yeah,
there.
when you get to Kittery, the miles per hour is 20.
Yeah, that's true. Like all of Route 1 is like
Gone within 20 miles over.
Yeah, right? All right, so 40 miles per hour we'll go with. If I would have plugged 18 in for the time, then my rate would have to have been miles per minutes, right? And it probably would have been a much larger number. Okay, so we'll go with that one. All right, so the next type of problems we have to get into are percent proportions. Do you guys remember your percent proportions? All right, well, it's good that I'm going to remind you of your percents. So remember, 1% as a decimal is 0.01, right? Or if we think about it as a fraction, 1% is 1 out of 100. Yeah? Okay. So hopefully remember how to convert our percents. That's just something like that's a basic thing. So whenever we're dealing with percent problems, what we like to think about is the percent proportion. And I always think in my head, part over whole equals your percent. Right? Because 1% would be 1 over 100. It's 1 apart out of the whole 100. So whenever you see, just for today, because these are easy percent problems, we're going to get to like the mixture percent problems, which get a little bit complicated later on down the road. But for now, we're just going to use this equation of partial amount over whole amount equals your percent. Just make sure that your percent is represented by a decimal. Okay. You might remember is over of equals percent over 100 or all of that stuff, right? Okay. So you're going to have a few percent problems that you're going to have to do for your homework. Specifically, where are they? 1, 2. Looks like 2% problems. And if you just set it up as this equation, it'll make your life really easy. Okay. All right, is everybody good? All right, so here's our first percent problem. We have a 50-liter mixture of acid. I feel like we're always mixing acid and water. In chemistry class, what do you guys actually mix? Do you mix things? You don't mix anything in chemistry class? You don't have beakers that you're mixing things in? Man, that's boring. So we have a 50-liter mixture of acid and water, which contains 10 liters of acid. And the question is asking, what is the percent of acid in the mixture? So we have a 50-liter beaker, I don't know, container. Inside of it has both acid and water. 10 liters of it is acid. So what is that percent? So what's the part? Which number? 10. What's the whole? 50. And that's going to be equal to X percent. So what is that? 10 divided by its 0.2, right? And I got to that because I know if I take that to 100 by timesing by 2 timesing by 2, that would get me 20%. So 0.2 is equal to X. 0.2 as a percent is 20%. Ethan?
You also just multiply it by 2 to get 100, like 20 over 100.
Right. And then you just know that it's 20%, right? Yep. Okay. All right, so let's get away from our acid mixture and go to, did I erase that too soon? Are we okay? And get to some money and percents. Sometimes your bank accounts have all sorts of interest rates. So here we have a savings account. So if a savings account balance of $3,550 earns 6% interest in 1 year, how much interest is earned? Okay. So again, we're still dealing with our same equation. Part over whole equals percent. My question is asking me how much interest is earned. So is that the part, the whole, or the percent? The part, right? Your interest is part of your whole account. So I'm going to put an X at the top of my fraction. My whole amount of money is that $3,550. And my percent as a decimal is 0.06. How do we solve for X? Multiply it. 0.06 times 3,550 is $213. Guess I'll show the multiplication. 3,550 multiplied on both sides gets us the 213. So you have $213 in your interest. Okay? So, would you be able to do a distance formula problem? Would you be able to do a percent problem? Yes? Alright. Now we're going to do You don't have to recopy this pie chart down, so don't worry about recreating that. So this was factual. I got this from the actual internet world. You will find that our textbook has really old examples, so I try to update them a little bit so that we're not talking about VCRs. Who even has a VCR? Do you guys have a VCR anymore? No? I don't even have one anymore. All right, so we've got in 2011, people in the United States spent an estimated $6 billion on Halloween-related purchases. And I would just not even write this last part. So use the graph to determine. We want to know how much of this amount was spent on candy. So if we look up here, candy was 31%. So in your notes, if you just want to write candy was 31% of that $6 billion. The rest says, so cards. Do you guys buy yourselves Halloween cards for people? You don't send, well, I guess when you become an adult, you send cards. Maybe that's a thing. When you guys go to college, you'll appreciate cards getting sent to you. You never received a Halloween card? I send my nephew a Halloween card every year. So like your aunts and uncles never sent you Halloween cards? So 5% was cards, 28% was decorations. I would have thought that was much higher. 31% is candy, and costumes was 36%. I feel like I would spend more money on decorations than a costume.
Now, more money on people really going on the
Really?
Yeah, but not everybody dresses up.
All right. So if candy was 31% of the whole, and the whole was 6 billion, so again, let's do our percent equation. Where's the x going to go? Part, whole, or percent? Part. On the bottom is 6 billion. How many zeros is that?
6. No, 7.
Well, 6 would get me to 6 million, so I need another 3 to get to the billion. So 9 is equal to 31%, so 0.31. So what does that get me? So 6, 1, 2, 3, 1, 2, 3, 1, 2, 3 times 0.31 is 186 with 1, 2, 3, 4, 5, 6, 7 zeros. 3, 4, 5, 6, 7. So how much money was spent on candy? Yeah, 1,860,000,000. Or we could be lazy and just write 1.86 billion. That would also work. Dollars. It's less zeros. Yeah. It's a lot of candy being purchased. Right? Alright. So we're good there? Okay, so now we're going to practice some problems. So if you want to either grab a practice space to do practice work on, or just your paper that's sitting there in front of you, grab something to do some problems